So it's number 2767. Partition string into minimum beautiful substrings. Given a binary string S, partition the string into one or more substrings such that each substring is beautiful. A string is beautiful if it doesn't contain leading zeros, and it's the binary representation of a number that is a power of 5. Return the minimum number of substring in such partition. If it is impossible to partition the string S into beautiful substrings, return -1. A substring is a contiguous sequence of characters in a string. Okay, so it is a binary string, and so every partition should be beautiful. And the definition of beautiful is that it doesn't contain leading zeros, and it's the binary representation of a number that is a power of 5. Okay, and so return the minimum number of partition. Okay. So like okay, string is either it's a string, so like it will be 0, like this, and this will be -1. Yeah, since it has leading zeros. And can it have empty? Okay, it cannot have empty string. Maybe like 1 1 1 1 1. Then it is 3, so it is but we can partition into 1 and 1, and it will be the power of 5, so it is 2. Okay. So like if we look at the last number, the last number in the string, like if we Okay, so if S I is beautiful, and the problem shrinks to string 0 to I minus 1. Yeah. So as the problem shrinks, it keeps repeating the same problem. So we can use dynamic programming approach. I would like to start with the depth first search to use like a recursion. So it will be DFSI. It means the minimum number of partition that makes every part is beautiful. The minimum number of partition with substring Si and if Si minus 2 or yeah, we can choose between like these two options, and so DFSI will be the minimum number, like the minimum of EFSI minus 1, like the problem, and there will be a partition, so plus 1 if Si minus 1 till I is beautiful. And we can have two and it will be let's see 0 to I, and this will be 0. And the boundaries will be I is 0. When I is 0, then it will be an empty string. And for empty string it will return zero. Wait, if the whole thing is beautiful, then that should be 0. Like there's no partition. So I think if I is 0, it should return -1. I want to check the previous, like if S is 1 till I, DFS will be 1, so it would be, it already will be an empty array. No, but this is 1 and it should be substring till 1, so it is 0. There is still, like it will partition as 1 and as 0 at index 0, so there's still 1 character. Yeah, okay, no problem. And this will be -1. And then we will see how to do with the beautiful thing. So for beautiful, first of all, as the leading thing cannot be 0, so as like Sj should not be 0, and S and binary representation should be the power of 5. So yeah, they're like, yeah, so like the most stupid solution will be using for loop, like to calculate each of the like binary 1 0 1 0, then you will have one oh, you'll have 0 like this, and 1 yeah, I'm thinking of if I use like prefix or suffix or something like like also dynamic programming, because it seems like they are calculating the same thing like repeatedly. So I think maybe suffix, prefix, suffix can solve the problem. Like if I have all the but okay, so I will write it down like to calculate the binary representation. Like a suffix, prefix, sum, but now will be product, or oh, its length is only 15, so yeah, it's kind of 15, so I will first write the main part up here, so it will be df if I equals 0, then return -1. Okay, then we will have result to be like the min part will be if we will have for loop, and for j in range I, so if as j to I is beautiful, then we will have minimum part with it like this and return the part. And for the answer, we'll have df as n. Oh, we haven't defined n. So n will be length of s. Okay, that still was the beautiful. I think I will do like representation is 0, and we'll have +1 and 4 in range +1 as well. So yeah, I will use the dynamic programming thing. So here you can like Oh, but yeah, the binary representation should be the power of 5. So if it is the power of 5, like the binary representation of 5 is 1. 5 is 1. Oh, 1. Will be can I check like it seems like ending with 101 or 001. Yeah, like if you end with yeah, because it seems like ending with 101 or 001 will be the binary representation. Its binary representation will be the power of 5. For 101, I think it is reasonable since it is 5. Like, yeah. But for this, it would be, yeah, I'm not sure, like 001. it is four. Yeah, I'm thinking of how if I want to confirm like the binary representation is 4 plus 1. It's fine. Good binaries. I don't know. Okay, I think we can just calculate like the power, because S length is 15, so we'll have 15 digits, and we can calculate the power of 5, the number, or the binary representation of the power of 5. Like we can do this first, then we can check if sj till I is equals this. I think it will be, and this is a constant time, I think, and we don't have to use space like this. Okay, we will have so we can have a like representation of 5, and it will be a set, and we will have a for loop for we can have the format thing like this. So for I think while length of the representation, so we have representation length, it is currently 0, so while we can do representation length will be the length of the power 5, and we will add power 5 to how do we add I will have the power x started from 0, so then x plus plus sounds, yeah, it's like for 5 with the power of 0, then it will be 0 here, and it will be 1, so the length will be 1, and 1 will be added to the representation set, and x will be added by 1, so it will be 1 now, sorry, it started from 0, it will be 1 now, and then it will be 5, so the representation will be 101, length will be 3, and it will be added to the set. X is added by 1. Okay, seems great. And if like it's 10 or something, the length is 15, can add to the set. Oh, but then if this is already 16, then it has no check. Can only be added after the length check, and then x will be added by 1, and it will have a new power. Yeah, will be better. But for the first one, it has no power 5. It is not declared. So power 5 will be, but wait, if it is inside it still, it has no damage, because there is no such stance that is larger than 15. So I don't think it's a problem, but yeah, I think power 5 will be fine. Will be 1, and power 5 should be 1. Power 5 will be added, and x will be added 1. This power 5 will be 5. This is 5. It will be 101. Then it will be 3, and it can be updated. Okay. So yeah, and this will be Sij in the representation set. Yeah. Oh. That's print. I don't think this is the problem. Oh, that should be. Okay, so here for DFS, if let's try run some example. For 0, n is 1, and so it will not run here, and I is 1, j is 0. So if 0 to 1 is indentation, no. So it will return if okay. At least this one is correct. Okay, let's see. 111. So 111 for 111, n is 3, and n is 3, and so I will be 3, and for j will be 0 now. 0 to 3 is 111 is 111 in set now. So we will move on to S1 3, 1 till 3, it will be 1 1. It's 1 1 in representation now. Okay, so we will have 2 3, so it will have 1. Is 1 in representation? Yes. So the main part, DFSJ will be 2. This will be 2 plus 1. So for I is 2, it will be 0 2, and 0 2 is 1 1. So it is not in the representation, and then it will be 1 2. 1 2 is in the representation. Is 1. This is the middle one, and okay, so it will be DFS 1. Yeah, for DFS 1, this is j is 0, so 0 1 is 0 1 in the representation. Yes, because it's 1. So DFS 0, DFS 0 will return or -1. I think maybe 0. Oh, because this is like 3 partitions, so so it's like the whole string will be 1 partition. Okay, then yeah, then this will be 0. Like the entire string and let's give it a catch. Okay.